Hello, from this video you will know how to draw such smooth anti-aliased lines using Rust and a few libraries. This demo uses SDL2 to output raw data. I have started programming on Rust about 4 months ago, so there may be some roughness. Also, before we start, I suggest you to subscribe to my channel. I make some interesting videos. So let's start. For first we need TOML file similar to this. Opt level must be 1 or more. I'll soon show why. So let's write code. For exploring purposes I type allow unused. And also this is uses needed for this demo. Then we will define some constants: FPS, width, height, window title. Also there is scale constant that must be delimiter for width and height. Function main as entry, and here is basic code needed to start with SDL2 to render image manually. Next pieces of initial code. Note variable start. This will be used later. Event pump is used to check all incoming events. This is code to set SDL2 buffer with data. Just because of this code to set bytes, there is some not optimized output binary with opt level 0. So we need to use opt level 1 as minimum. Then we need to type canvas present to display buffer. We check time passed from start of this iteration and program sleeps if there is time before next frame. Launch cargo run, wait for compilation. And this is the result we got so far. Let's now define some types. Image RGB is our data buffer to draw lines. Note that I am using order channels, then height, then width. This is not very good order for graphics, and you will see why. Let's define canvas struct, where we will draw. And its method clear. We need to get dimensions of data. And then set every pixel to color. Note that color components of argument is float from 0 to 1, while data's RGB is unsigned byte from 0 to 255. I mean self data. Now method new. Let's then create canvas variable in main function. and define a background color. Plane must be mutable. And we will clear it in the loop. Also, yes, it's better to pass a reference to color. We don't need to move or copy it. In copying section, let's replace immediate values with planes data. This is our result. We will draw stuff in function draw that takes mutable reference to canvas. Let's add canvas method line to draw line between 2 points. Also, we need to multiply points coordinates to width and height. This is how algorithm works. We iterate over main coordinate as integer, then adding a half to value and computing opposite coordinate as float. In this example, main coordinate is x, while opposite is y. I defined another structure which will implement iterator trait. It will return tuple from discrete line main coordinate and float value of opposite coordinate. Iternum is number of iterations. You can pause the video to observe the code. Let's dry this code a little. We will iterate over some coordinates and set our canvas data directly. Defining some points to pass to line method. And this is our result. Let's look at pixels in another scale. We need to edit our copying code a little. I added a new value to canvas struct. It's a flag to start anti-aliasing. Also, we need to define dedicated functions to manipulate pixels. We will set pixel value only if coordinates fits, else just skip. Oh, I mean as each size, of course. Now we need a function for Shaolin-Woo's algorithm. I named it anti-aliasing values. This algorithm works as previous, but it colors two pixels of opposite coordinate. Saturation depends on distance from pixel center to line opposite coordinate. Now let's set pixels using these values. And this is what we have got. You can see that line is drawn as if on black background. Let's fix this. We need a function for alpha blending. Also, we need a function to get pixel value. If coordinates doesn't fit, simply return black pixel. You can see here one of the disadvantages of pixel ordering that I have chosen. So we set a blended color for bottom and top pixels. I did a mistake in getPixel. Y and X are swapped. After this, that's our result for now. Let's now do the same code but for other coordinates. That's not a pretty solution, but I don't know how to do better. So now we can draw and more vertical lines. Let's then make a function to draw line 3. And this is our result so far. Then we can make smooth lines using Chaikin's algorithm. Here I take the same input twice, take all but last, zip it with skipped first element, and we can process neighbors. Chaikin's algorithm works very simply. Get lines between points, do a new line on 25% and 75% of length, and then connect new corners. Not to do ends cutting and to define number of subdivisions, we need this function. Let's now smooth with 3 subdivisions. This is if we set 1 subdivision. This for 2 subdivisions. Let's check without scale. Line not too smooth. Also we can see strange artifacts, gaps. Let's set subdivisions to 5. This is new look, however one gap is still there, but it's not very unsatisfactory. Let's now create a function to generate sinusoidal shapes. Did you know that combining sinusoidal functions with different coefficients we can get very variety shapes? This is topic what about Fourier transform is. These are coefficients that I already picked up. Let's now define a piece of code to generate shape from these coefficients. And that's what we have got. Let's now create a few more lines. Also, this is where we start to use start variable from main function. Let's compile it in release mode so we get most optimized version to get more FPS. This is our current result. What if we color these lines? Now they are red. Let's do separated lines. We will start from very simple coefficients, generating green line like we already generated red lines. I want to make a more straight lines, so I changed coefficients. And this is the result. Let's now add some smaller functions coefficients. We will generate multiple coefficients like for red lines. This is what we have got, not pretty. Maybe I need to remove this normalization factor from complex function and add the limiter directly to generation code pieces. Way better. Now we will separate these code pieces. Everything these aren't pretty, but enough for our demo. And this is final result. Now let's remove allowing unused, and also we didn't need SDL2 video star, my mistake. Remove some parentheses. Add handling of return result values. And that's all. You can find link to repo in description. Thank you for watching, don't forget to subscribe and like video. You can also watch my previous videos, they are more entertainment.